All right, everybody, welcome to Vox Veritas Live, Episode 3, Practical Neuroscience. So, thanks again for tuning in to our lecture series. I'm Dave Carreon, a psychiatrist and neuroscience researcher at Stanford, and tonight's lecture is going to be more practical neuroscience. If you weren't here last week, all our lectures are saved on YouTube, and you are welcome to go at your own pace, however fast that happens to be. Now, before we get started, like always, we've got some announcements for our live audience. You're always welcome to ask me questions by YouTube, Twitter, or email. I'll also try to answer as many as I can at the end of lecture. So feel free to ask questions about last week or about neuroscience in general, or whatever happens to cross your mind. For those watching on YouTube afterwards, again, feel free to ask questions. We're going to have chat again this week, so the rules are simple. Watch your language, treat others the way you want to be treated, and have fun. If you break the rules, you will get a warning before you are banned, and if you want to be unbanned, send me an email next week. So without further ado, say hello to each other, those of you who happen to be on chat, and we will move forward. So this week is we're going to be talking about some super exciting stuff. So just to review from last week and what we've been doing all this time, the first thing to talk about is, number one, the brain is totally awesome. I think you already know that if you're tuning into a neuroscience lecture. So number one, the brain is totally awesome. Number two, the brain is extremely flexible. We saw all those incredible examples of people who dramatically changed their brain and how their brain worked. Number three, your mind makes it real. This is the incredible ability for your brain to change what thoughts you have to change your brain. And number four, attention changes the brain. So we're going to be talking about number four today with today's lecture series. So the first thing we're going to talk about is something called the selective attention task. Now, it's too bad that we can't do video through here, but when you get a chance, Google a few selective attention tasks. And the way it works is basically you're supposed to do something to take your attention up, and then halfway through the video, a person in a gorilla costume walks through the scene, pounds on her chest, and then walks off the scene. And you ask half the audience, so do you notice anything strange about the video? And most people say, no, well, I didn't notice anything strange. And you sort of wonder, how can you watch a video of a gorilla walking through the scene and not notice that there's a gorilla there? This is kind of astonishing. So the question is, the answer is, we only have so much attention, and it's actually astonishing how little attention we actually have. So imagine you're in a library and you've got shelves of books, and you're running down this corridor, and you've got all of these books that are passing you by every second. You've got books passing you by, and basically the amount of information that you're able to actually spend your attention on is about 4 words of all of those books you're passing by. Now, how do I get that number? Well, we know that we were able to look at the amount of information that is able to pass through each part of, for example, the visual system. So we know about 1.2 kilobytes per second is able to pass through the optic nerve, the part connecting your eyeball to the back of your brain, whereas 1.2 gigabytes per second is processed by the retina itself. So you've got this huge reduction in the amount of data that's transferred. A lot of it's been processed, but then ultimately the amount that you're able to actually pay attention to is only about 12 bytes per second. This is tiny amount of information that you have as part of your attentional bandwidth. Now, what this means is that you can pretty well keep all of the attention that you'll ever have for your whole life on a 20 gigabyte SD card. So your phones have about that much storage space these days. So this is a incredible idea that we have this incredibly precious resource called attention, and that we kind of use it up. That we almost we can run out of attention. And so this is actually has a lot of other implications. So when you look at it's not just attention per se, but the ability to attend in a positive way. So another activity that looks like you could run out of is compassion, or they did a study in Israel, and they actually had they looked at these people who were up for parole, so people who had committed crimes, and they were looking at all of these factors and trying to explain why was it that some people got released on parole and why was it that other people didn't. And in the end, the conclusion was, well, the biggest factor predicting who would get let off and who would stay in was not the severity of the crime, was not the race of the person, was not that whether this is a first or second offense. The biggest factor was how long had it been since the judge had eaten. The judge, the amount of time that the judge had eaten was immediately after a mealtime. So the first case of the morning, you've got about an 80% chance of going home on parole. Afterwards, after that time, at the last case of the day, only about a 20% chance of getting parole. And right after lunch, it jumps back up to a decent part and then kind of trails off. So that this is again brings up this idea that we have this limited attentional resource, and there's all kinds of things we could do to improve our attention. And I'll expand on this a little bit later. Good food, exercise, and sleep are some ways that we can do that. So these are things that people have heard people have encouraged you to do: eat well and exercise and sleep. But the question is, what is that actually doing? How is that actually working? And so I'm going to take a case study, a particular condition, a severe condition, where attention is really front and center. And so there's a condition called obsessive compulsive disorder. And in this condition, people have these compulsions. The people who have this condition have compulsions, for example, to wash their hands repeatedly. And it's not something that's rational. It's not something that they think is a good idea. It's something they think is a bad idea, but they still nevertheless have this compulsion: I must wash my hands, otherwise something bad is going to happen. And so in serious conditions, and people who have this in a significant way, you'll start to see they'll wash their hands raw. They won't be able to actually and they won't be able to stop themselves. And so there's a lot of difficulty in treating these people because they know it's irrational. You don't need to convince them that it's irrational, but what they need help with is redirecting their attention. And so one of the best treatments that we know about for obsessive compulsive disorder is something called mindfulness. And mindfulness, a lot of people talk about mindfulness, but one definition of mindfulness is a third-person perspective on a first-person experience. Another way to look at that is you're sort of looking at your own thoughts or experiences like they were somebody else's, being able to impartially evaluate them. So rather than being part of your experiences, you're a little bit you're separate from them. So you're able to watch from the outside and then make determinations and judgments. And this is actually this is a method developed by a guy named Jeff Schwartz out of UCLA. And so what he's done and what he's shown is that when you have this condition, you have this these negative circuits, these circuits that are associated with the disease, indicated by the red arrows. And as you continue to engage in these conditions, the engage in the behaviors of washing the hands, for example, these circuits strengthen and continue to get worse and worse. Whereas when you redirect your attention, rather than identify that, hey, this isn't me, this is my brain. I identify that is not a part of what you want to be and what your ideas are, but that they're a brain disease. And then what happens? And then you redirect. The method is redirecting your attention to something positive. And as you continue to do that again and again and again, you will develop a new positive brain circuit, a brain circuit that isn't associated with the condition. And you actually see this in studies. This is one of the very first studies of the brain that shows that with mindfulness-based, with non-pharmacological treatment, without using drugs, you're able to get an effect where the caudate and the thalamus, two regions associated with this faulty circuit, go from being hyperactive before treatment to closer to a normal level of activity after treatment. And so it's incredible that by redirecting attention and by just teaching people how to redirect their attention, you're actually causing changes to brain circuits in a way that's connected to actually overcoming the disease. So this is actually really encouraging stuff, that you're able to actually change your brain in ways that are positive by redirecting your attention and learning to redirect your attention. All right, this guy, this is back in the olden days. Apparently, people used to have much more awesome beards than we do today. This is Leo Tolstoy, and according to legend, he was told by his brother to stand in a corner until he could stop thinking about a white bear. And his brother came back a while later and said, "What are you doing?" And he replied, "I can't stop thinking about the white bear." Now, this is strange. Most people don't go around thinking about white bears, and then as soon as they are told, "Don't think about a white bear," what happens? Well, a white bear pops into their minds. And you could try it right now. So this is I'm going to give you a challenge. So for the next 20 seconds or so, I want you to not think about a white bear. Think about whatever you want. Starting right now, do not think about a white bear. You can think about anything else in the whole world that you want to think about, but just try to avoid white bears or white bear related things. It's really hard, isn't it? It's really hard to not think about a white bear. You could think about the white bear, but then as soon as you realize, I'm not thinking about a white bear, oh, you just did it again. So you've got this whole back and forth of trying to push this out of your brain, but then coming back in. And some people explain this in a lot of ways, that there's a part of the brain that's the monitor, and that the monitor's job is to check to see whether everything is the way you want it to be. And a not command is very difficult for it, because every time it says, is there no white bear in my brain? Well, there it goes. There's the white bear back in your brain as a stop. But this is actually a cognitive task, a task that neuroscientists and psychologists use to deplete people's willpower. They'll tell them, for the next minute, try not to think about a white bear. And this is a surefire way to make them tired and use up their willpower. And it turns out that this pattern of when you repeatedly use your attention and redirect your attention, it has effects on your brain in the long term. Let me tell you another line of research that's connected to actually what I do and what I do with my professional research. This is another picture of a brain, and this part right here, the inferior frontal gyrus. This was a study showing that damage in the inferior frontal gyrus, and so this is if you look at the brain kind of head on, and then you go to the right side, and you kind of go down here, down the central sulcus here, and then move forward one. You have the inferior frontal gyrus right here on the right. That part of the brain, small as it is correlated with a variety of self-control tasks. So one of these tasks has to do with stopping when you're told to stop. And they found in this study that people with brain damage in this particular region, the more brain damage you had, the slower you got on this particular task. So it's interesting, right? And this is part of a long line of research showing specific brain damage causing specific deficits. But it's not just in the brain damage; it's also in people who have addictions to methamphetamines. So the same region, inferior frontal gyrus on the right, you start to atrophy the amount of actual gray matter that you have on the inferior frontal gyrus, the amount of neurons that are processing information, shrink. There's fewer of them when people who do methamphetamine, who do this particular drug. And so the question is this process something that you were just born with fewer neurons there, and then you end up becoming addicted to drugs, or is it that you can actually change over the course of time the number of neurons that you have in that region? And we don't have the full answer to that question yet, but it looks like there is some evidence to suggest you could change this. So I was trying to figure out for this talk I want a metaphor, and I need a lot of different pictures of a particular maybe an animal in different positions, and say, well, what is the internet? What animal does the internet have in abundance? And the answer was clear: cats. So cats are going to be our metaphor here, and I'm going to use this is excited cat and this is sleepy cat, and use these as different states of the brain. So how do you go from so there's a lot of studies that a particular lab, the Baumeister lab, did, and he showed that if you have people not pay attention to their posture, so slouch, as I tend to do a lot, you don't have any changes in your willpower. But if you tell them, pay attention to your posture, and whenever you realize, sit up straight. And so people who did that over the course of a few weeks had improved willpower. They actually were able to measure improvements in people's willpower. And this is strange, that this seemingly completely different task, thinking about sitting up straight, that would be connected to this other task of resisting temptation, or holding onto a hand grip, or doing a puzzle. It turns out that willpower is universal, or is cross-domain, that when you run out of willpower in one area, you run out of willpower in all areas. It's sort of a common source that you run out of. And when you build it in one area, you build it in a lot of areas. What else? What is another example of this effect? Turns out that language, when you tell people don't monitor your speech, in the control group, and then the experimental group, they said, we want you to not use contractions, don't say don't, say do not, and don't swear, and try to do that for 2 weeks. And it turns out that people who were in that condition also improved their willpower. Consciously trying to monitor their language on a moment-by-moment basis was helped them build their willpower. What else? There was another one that they did with handedness. They had right-handed people try to do do things with their left hand. So rather than open doors with their right hand, they'd have them open it with their left hand. Rather than having them eat food with their right hand, they'd have them eat food with their left hand. By having to do that, you have to pay attention to your hand over the course of that experiment, and they got better at these willpower tasks too. So there's a lot of different tasks. Now, the one that has been most consistent, one of the biggest ways to improve your willpower, is exercise, physical exercise. And again, you think, wait a minute, what does physical exercise have to do with anything? I thought this was a mental thing, mind over matter, right? Well, it turns out that actually exercise is a profoundly involving task. In order to be able to do this, to do exercise, it takes a lot of your brain. And so normally we think of, okay, the motor cortex. So normally we think of this region of the brain right here, the motor strip. So if you kind of zoom out on the top, it looks it's this one here. That part of the brain, we think that that's the part of the brain that's involved with doing motor activities. But it turns out that they did a study looking at a hand grip task. So they had people grab a hand grip and then relax, and then do that until they got tired. And what happened? Well, turns out that they started to identify that parts of the brain, even in the front, even in the part that's normally associated with things like memory and cognitive processing, things over here got a lot more active. They actually increased their activity. So and they started working in conjunction with the part of the brain that was actually sending that final command to squeeze the hand grip. So it was like the whole brain was coordinating to just do this simple muscular task. And so when we do sports or when we do physical exercise, it's actually causing our brain to work in concert together. So it's actually a really big and really important thing that exercise is more than just the physical. So this is all to say, attention in all of these different tasks, whether it be in mindfulness, just internally causing your attention to shift from one thing that you don't want it to be to something else that you do want it to be, or whether it be something silly like using your left hand, or trying not to swear, or sitting up straight. All of these things that are not connected, not seemingly connected, actually are connected. And then finally, exercise is another way to redirect your attention. And that this is something that seems to be a skill that you can build, something that gets stronger, something that you can actually change your brain, and so that you're more able to direct your attention in ways that you want. So this is the I think the final take-home point of this series. So I told you at the beginning that the brain is totally awesome, that we have this incredible organ in our skull that has the ability to change and adapt and is connected and do all this processing. We have that at our disposal. But one of the coolest properties about it is that it's extremely flexible. And so what does that do for us? That allows the things that we think and the thoughts that we have to actually cause it to become real in a physical sense. And I think, as a takeaway, the most practical thing that we can talk about, the most practical thing that you can do with this information, is start to practice shifting your attention. Start to practice doing hard things with your attention. Maybe it is one of these silly tasks. Maybe it is trying to use your left hand if you're not left-handed, or maybe it's trying to improve your language, or maybe it's some other thing that I haven't talked about, but something that's challenging, something that you haven't done before, something that requires you to shift your attention, or maybe it will be taking up starting to exercise if you don't normally exercise, or exercising more if you already do. This is a way that you can control your brain and start to change your brain in one of the most important ways possible. So, in conclusion, the conclusion of this series is use your brain. Use your brain. You have this incredible organ, this incredible thing inside your skull, and the great thing about it is that you could use it. That it does have this ability to adapt and change and do new things that you never thought possible. So, with that, I'm going to wrap up the series of practical neuroscience. That is the end of our 3-part series on practical neuroscience. Next week, and so if you have any questions, please send them in. But next week we're going to be talking about the neuroscience of happiness and neuroscience. So I'm going to be telling you a lot of the studies and ideas, and ancient and modern, about how to live the good life, how to live a flourishing life. And so be sure to tune in next week for that. So this week, question number 1 is, are computers smarter than people? That is an excellent question, and I think that this question really animates a lot of the discussion about what the brain is and how the brain works. I think that on some levels the answer is easy. The answer is that, well, how much math can you do? I can multiply a 1, maybe 2-digit number in my head, and it takes me a long time. And computers can do that with ease much faster. But I think the question is, what do we mean by smart? What is smartness? And I think that the answer to the answer to that question is really profound, and it really gets to to some really profound philosophical issues about what does make us human. How are we, or are we different than computers? Are we just slow computers? I think that right now, while computers are really good at math, there's a whole bunch of things that we're still better at. So that computers can't quite do as well as we can. So I know in my own field, it's extremely difficult to get computers to be helpful with diagnosis. Trying to in medicine or psychiatry, getting computers to help us predict what a patient has based on a set of symptoms. It's something that a computer probably will be better at us at before too long, but right now, humans are better than computers. But then there's questions about things like philosophy or religion or coming up with logical propositions. The ability for humans to do these things is something that maybe computers will never be able to do. But these questions are very profound, and it's a great question. Okay, question number 2: How do you measure willpower? That's an excellent question. It's a question that I actually have struggled with myself, because it's part of my research. So there's ways that are very quantitative but not very believable, or less believable, and then there's ways that are very believable but really difficult to measure in a lab. So some constructs are a press a button whenever don't press a button whenever you see this sign or hear this tone, something like a stop signal task. And that one's really good at getting a solid number. The trouble is that does that really connect with, not eating chocolate, or, trying to resist, trying to make myself go to the gym. Those don't seem very, very plausibly connected, but there's a lot of neuroscience evidence to suggest that they are. But there's that end of the spectrum. On the other end of the spectrum, researchers who will have people have a bowl of M&Ms out and allow them to do a taste test and then measure how many M&Ms they actually ate. So there's this whole spectrum of interesting experiments for measuring willpower. I could wax large about this at another time, and maybe I will. I'll add some slides at the beginning of next lecture. Question 3: Could you use attention to cure diseases like dyslexia and ADHD? That's another excellent question. I'll answer the ADHD one first. There are actually people who are doing research using mindfulness techniques in the treatment of ADHD. I actually don't know how the literature has advanced since the past few years, but it's very plausible that you could get improvements in your attention even in conditions like ADHD by experience and by practice. Now, of course, someone with attention deficit disorder is going to have a lot more difficulty with these tasks than other people, but that just as somebody who is physically smaller or physically weaker is going to have more trouble at the gym when they first get started, but that doesn't mean that they too aren't going to get stronger if they practice. Dyslexia is another question. You can use attention, but you have to use it in special ways. And there are actually special trainings that use of neuroplasticity to help with the treatment of attention of dyslexia. And I think it's I believe it's Michael Merzenich who's done some work in that. And then question 4 is: would it be possible to be able to lift more by thinking you could, by placebo? It's an excellent question. That you guys are full of great questions. I think the question about the lifting more with placebo, there's all these stories about the mother whose child is trapped under the car, and the frail lady lifts the car off the child and he gets out. We hear these stories and say, well, maybe a very heavy car. But I think the studies that we had seen from last week with the thinking about moving your abductor digiti minimi, or the studies showing the differences in pain, make it plausible that when you think you can, you actually lift more. And it's well known by people who do lift that when you have a buddy with you, you lift more. When you have that encouragement, when you have that sort of peer pressure. So it's not just a physical factor of muscles. It's also in large part up here. And then this will be the last question of the night. Does exercise make you smarter? Um, I think that the answer is yes, if we understand smartness in the full sense. So smartness in terms of your ability to do a particular calculation or know certain facts, maybe not in the short term, but in terms of when we look at a smart person, when we look at somebody who is really in control of themselves and of their mind, it's not just about raw horsepower of the brain, which is a strange sort of, I mean, even that would be difficult to define. It's much more about being able to consistently make good decisions and make and direct yourself, your body and brain together in ways that you want to go. And so in the long term, the smart person is the person who's able to sit down and do their homework, is able to study and to memorize the things that need to be memorized. And so, yeah, the person with willpower, the person who's practiced again and again and again and again with exercise, very well may be smarter than the person who doesn't exercise, who has just as much intellectual intellectual endowment as at the beginning. So I'd say, yeah, that you probably could go from you could increase your you can certainly increase your ability to do well in school by exercising if you don't exercise. I think that it's again another. You guys are asking great questions, so keep it up. So any more questions, please tweet. Here again is the information. So tweet or email or better yet, leave a comment on YouTube, and I'll get back to those questions next week. So thank you so much for watching. We love having you. Love having this live audience. So keep on coming back, and feel free to ask me questions or give me suggestions. So have a wonderful Sunday night, and I will see you next week.